Welcome to ClickMyProject.com. Our project title is Fine-Grained Food Classification using streamlit. This is our abstract. Creation of an autonomous food identification system offers a number of intuitive applications, including managing food waste, advertising calorie estimate, and tracking daily dietary intake. Despite the significance of this topic, there aren't many relatable papers available. Furthermore, the literature comparison only took into the account best short performance without taking the most popular approach of the average across numerous trials. This process makes you understand the different types of foods in our society. This is just a small representation of the recognition of foods using CNN. Finally, feed the model to the streamlit framework and finally predict the food variety. This is our objective. Develop a food predictors, minimize the time for creating the classification of the food varieties, improve the performance time. And this is a system architecture. First one is we have used the image data set. Here we use the 101 tiny image data set, and from that first module is the data selection. Next module is the data pre-processing, and then data splitting. In data splitting, we have to split the data into training and testing data as a ratio 8:2%. Next module is the classification. Here we use the deep learning classification algorithm CNN, and then next one is the prediction. By using the CNN algorithm, we have to predict the each and every image of the data set of the image. For then the performance analysis. Performance analysis here is that we have to dump the model and then import the model as the streamlit web framework. This is a flow diagram. Then the first one is the data selection. Then for data pre-processing. Data pre-processing, we have to do process missing values and the label encoding. And then data splitting, here we split the data into training and testing as a ratio 8:2. And then classification, here we use the deep learning classification CNN and prediction performance analysis of the CNN, accuracy loss and the training loss and the testing loss. And then this is a use case diagram from the user point of view. What are the process we done in the process? First one is the data selection, and then data pre-processing, data splitting, classification, prediction, and then performance analysis. This is what written by a user, and then this is encoded and decoded in the system. And this is a ER diagram. From the start point, we have to first load the data set and select the data what we have to done it, and then data pre-processing, splitting, classification, prediction, and performance analysis. And this is a sequence diagram. From the start point, we have to select the data and load data, and then select data selection. After data selection, data pre-processing, and then model selection and the classification. In the data splitting, we have to split it, and then performance analysis, and then predict the each and every image of the data set. After executing our process, we have first to find the 10 classes belonging to the 1200 images and training images, testing images. By using CNN, we have to use the approaches. We have the 10 approaches right now here. We have the validity, accuracy, and then loss, and then finally our predicted array. That is what the test generated array, and then our test images array. This is a streamlit process. So only after executing by the streamlit command, our browser will go to the streamlit web page. After getting our localhost in Google, we type that localhost, we find that streamlit page. And then here is our title food classification. Here we use the upload file used by the this is it predict like this.